Let's see some questions. Okay. The position time graphs for two children A and B returning from their school O to their homes P and Q respectively are shown in the figure. Choose the correct entries in the brackets below. A or B lives closer to school than B or A. So they are asking who lives closer to the school. Let us see the answer. The distance of A's home from school is OP. So this is A's home and this is B's home. So distance of home, A's home from school is OP, while B's home is OQ. We can very well see OQ is greater than OP. OQ is greater than, OQ is this much. OP is only this much. So OQ is greater than OP. So A lives closer to the school than B. So definitely OP is smaller. So A lives closer to the school than B. A or B starts from the school earlier than B or A. For x equals to 0, t equals to 0 for A, but t is greater than 0 for B. It means A starts from the school earlier than B. So let us see. When x is equals to 0, this is the distance axis. When x is equals to 0, for A, this is A's graph, t is 0. When x is equals to 0, for A, t is also equal to 0. When x equals to 0, in B's graph, time has some value in it. Maybe 1 second or 2 seconds. It has some value. So it is not started in 0 seconds. It has started at some time later. So who starts from the school earlier? A starts from the school earlier than B. A or B walks faster than B or A. The speed is given by the slope of x graph. Since slope of graph for B is greater than that of graph for A, speed of B is greater than that of A, B walks faster than A. So this is position time graphs. So this gives us speed. Position time graph, that is distance by time, is speed. So this graph slope will give us speed. So from seeing this graph, this is theta and this theta 1 and this is theta 2. Definitely theta 2 is greater than theta 1. If theta 2 is greater than theta 1, tan theta 2 is greater than tan theta 1, velocity at 2, whereas velocity of B is greater than that of velocity of A. So B walks faster than A. A and B reach the home at same or different time. Corresponding to points both P and Q, the value of T is same. It means that A and B both reach home at the same time. So when they are reaching home, A when it reaches home and B when it reaches the home, the timeline is constant. So they were reaching the home at the same time. Suppose it is 5 seconds, so here also 5 seconds, here also 5 seconds. A or B overtakes B or A on the road once or twice. The graphs for A and B intersect each other only once. Hence, meet A and B each other only once on their way to home. So, the graphs were intersecting only once. So, only at that time they were intersecting. So, only one time they were overtaking. Since B starts from the school later than A and walks faster than A, hence B overtakes A on the road. So B had started later. So A has started when the time was 0, but it started later. B started later, but B is walking faster than A. That is why the slope is more. So B is walking faster than A, and also it is overtaking once. So who is overtaking? B is overtaking A because B's velocity is more than A's velocity. Let us see the next question. A woman starts from her home at 9 a.m. and walks with a speed of 5 km per hour on a straight road up to her office 2.5 km away. Stays there at the office up to 5 p.m. and returns home by an auto with the speed of 25 km per hour. Plot xt graph for her motion. Time at which the woman leaves her home is 9 a.m. Time taken her in reaching the office is 2.5 km, that is distance by velocity or speed 5 km per hour. 2.5 km by 5 km per hour, that is half hours, that is 30 minutes. So this is the time taken by her to reach her office, that is 30 minutes. Time at which she reaches office is 9:30 a.m. So 9 a.m. she starts walking and she took 30 minutes to reach her office. So now she is reaching the office at 9:30 a.m. Between 9:30 a.m. and 5 p.m. she remains in her office. That is, time is going but she is not moving. She is remaining in the office. Time taken in returning to home. Returning to home, the same distance. So let us take it like this. This is her home. Suppose this is her office. She is going with speed 5 km per hour. Now she is staying there for up to 5 p.m. she is staying there and she is returning to home with another speed, that is 25 km per hour, through an auto. So now what is the time taken here? So for this she took 30 minutes. For this, how much time she is taking? 2.5 distance by time, by velocity is 25 km per hour, that is 1 by 10 hour. 1 by 10 hour, how would you convert into minutes? 1 by 10 into 60, that is 6 minutes. So she is taking 6 minutes to come back to her home. Time at which she comes home is 5-6 p.m. So up to 5 p.m. she was there in the office. Then she is taking 6 minutes to reach her home again. So at 5-6 p.m. she is in her home. So the graph looks like this. So she is starting at 9 o'clock. She is starting from home. That is 0 meter. So this is 0 meter. She is starting to walk with the 5 km per hour and she is reaching office, which is 2.5 kilometers away. She is reaching there by 9:30. She is in the office. Then her position is not changing. She is remaining in the same office for 9:30. From 9:30 to 5 p.m. she is remaining in the office. There is no velocity because slope is 0. So there is no velocity. Then we have negative slope. Already we have discussed, if there is negative slope then it is returning back to the reference point. From 5 p.m. to 5-6 p.m. for 6 minutes she had walked when she had reached her home. A drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward, followed again by 5 steps forward and 3 steps backward, and so on. Each step is 1 meter long and requires 1 second. Plot xt graph for his motion. Determine graphically and otherwise how long the drunkard takes to fall in the pit 13 meter away from the start. So let us see this question. So there is a drunkard. He is taking 5 steps forward and 3 steps backward, and each step is 1 meter long and each step takes 1 second. It is given in the question, and a pit is 13 meter away from the start. So they are asking how much time will it take for him to fall in the pit. So let us see. He is taking 5 steps. 1, 2, 3, 4, 5. 5 steps forward and 3 steps backward. 1, 2, 3. So totally 8 steps. 8 seconds it would have taken, but the net displacement was only 2 steps. So he must have covered only 2 meters. The net displacement is only 2 meters. So in 8 seconds he covered only 2 meters. That is his net displacement. Similarly, he would have covered next 5 meters. That is next 5 steps. 1, 2, 3, 4, 5. And also backward 1, 2, 3. Now he is here. Previously he was here. Now he is here. First his displacement was 2 meter. Next his displacement again is 2 meter only. So totally this is 8 seconds and this is 8 seconds. So in 16 seconds he covered 4 meters. Okay. Similarly he would have done the same for next time. Then he would have covered 8 ones are 8, 8 twos are 16, 8 threes are 24. In 24 seconds he would have covered 6 meters. Similarly he would have done again 32 seconds he would have covered 8 meters. Now he must be here. So this is a 2 meter, this is a 2 meter, and now he is standing here. Now we have already covered 8 meters. Now if he is taking, so the pit is 13 meter away, 13 minus 8 is 5. So now he has to take only 5 steps to fall in the pit. So he will go 1, 2, 3, 4, 5. He won't be coming back because here is the pit. So he will fall into the pit. He won't come back. So he would have taken extra only 5 steps. Already 32 seconds he covered 8 meters. Next he took only 5 steps because he won't be returning back. So 5 steps means 5 meters. 5 meters means 5 seconds. So 32 plus 5, 37 seconds. So he must have taken 37 seconds to fall in the pit, which is 13 meters away from the initial position. Let us see this graphically. So he is starting from 0 meter when it was 0 seconds. Then he is going up to 5 meters in 5 seconds. Then time is increasing. 5 becomes 6, 7 and 8 seconds. It is increasing, but time is increasing. From here to here time is increasing, but distance has reduced. He came back. So his net displacement is only 2 meters. Again he is starting from here. Again time is increasing. So again time is increasing. He is taking 5 steps forward and 3 steps backward. Again in 8 seconds he covered, his net displacement is now 4 meter. Next he is covering 5 meters forward, 3 meters backward, and then his net displacement is 6 meters. Similarly again he is moving 5 steps forward and 3 steps backward. Now his net displacement is 8 meters. Then he is covering 5 more meters in 5 seconds, and then it is becoming 13, and here is the pit and he has fallen there. Two trains A and B, each of length 400 meter, are moving on parallel tracks with a uniform speed of 72 km per hour in same direction, A being ahead of B. The driver of B decides to overtake A and accelerates by 1 meter per second square. After 50 seconds, the guard of B just moves past the driver of A. What was the original distance between two trains? Okay, let us try to understand the question. So there are two trains A and B, and they are saying A is being ahead of B. So if A is here, this is 400 meter, A, B was somewhere here. This is B. The driver of B decides to overtake A. So they both were moving with 72 km per hour. 72 km per hour. Let us convert it into meter per second. 72 kilometer 1000 meter by 1 hour 3600 seconds. So 20 meter per second. So they are moving, both the trains are moving with 20 meter per second. Now Driver of B decides to overtake A and accelerates by 1 meter per second square. So who is accelerating? B is accelerating with 1 meter per second square. And after 50 seconds, B just moves past the driver. So after 50 seconds, A comes here, but B is here. B is here. So their ends are just crossing like this. Okay, now what is the original distance between the two trains? So they are asking this distance, original distance they are asking. Okay, let us see. This is not accelerating. It is moving at 20 meter per second, and also it is covering 50 seconds. After 50 seconds, its distance is here. It is here after 50 seconds. But this has accelerated, and after 50 seconds it comes here. So let us find their distances. What distances they would have covered. I am taking this starting point and this starting point. So this distance I am going to find. This to this distance. This it's starting from here. This starting point where it was earlier. Now where its starting point is. What is this distance? Let us see. S is equals to V into T. 50 seconds into time is 20 meter per second in 50 seconds. That is 1000 meter. So this distance is 1000 meter. Okay. Now let us see how much distance B has travelled. S is equals to, here the motion is accelerated. So we have to use ut plus half at square, and it is accelerated. So it is plus A. U is actually it was travelling with 20 meter per second. U T 50 plus half A 1 meter per second square T square 50 square. So this we are getting 2250 meters. So B's starting point was earlier here, now it is here. This total distance is 2250 meters. Now we have everything. Now we have to calculate the distance between the two trains earlier. Original distance between them we can calculate now very easily. This to this point, it is 2250 meter. We want this meter, we want this distance, we want, that is what is being asked. So if I am eliminating this distance, and this distance, then I will get this distance. So 2250 minus this is 400 meters. So this is 400 minus 400. This is 1000 minus 400. So it will be 2250 minus 1800. 450. So that was the initial distance between the two trains. Next question. A man walks on a straight road from his home to market 2.5 km away with a speed of 5 km per hour. Finding the market closed, he instantly turns and walks back with a speed of 7.5 km per hour. What is the magnitude of average velocity and average speed of the man over the interval of time 0 to 30 minutes, 0 to 50 minutes, 0 to 40 minutes? Okay, let us see. So a man is starting to walk on a straight road from his home to a market which is here. Suppose let us say this is market, which is 2.5 km away. So the distance between the home and the market is 2.5 km with a speed. So he is going with the speed of 5 km per hour. Finding the market closed, he instantly turns and walks back with the speed of 7.5 km per hour. how the way he is coming. He is coming with 7.5 km per hour. What is the magnitude of average velocity and average speed? So we have to find average velocity and average speed for these time intervals we have asked for. Okay, let us try to understand. Okay, the distance is 2.5 kilometers. Speed of the man while going from his home to the market. Let us take it as V1, that is equals to 5 km per hour. Okay, let us find the time which he takes for going. T1 is the time taken for him to go from his home to the market. That is equals to distance by velocity 2.5 by 5 km. 2.5 km by 5 km per hour. That is equals to 0.5. 0.5 hour. 0.5 hour is 30 minutes. So we take 30 minutes to go from the home to the market. And while what is the time taken in walking back? Again he is covering the same distance. So there is no change in the distance, that is 2.5 kilometers. But speed is changed. V2 equals to 7.5 kilometers per hour. So what is the time taken by him to reach home from the market? That is 2.5 by 7.5. That is 1 by 3. 1 by 3 hours. That is 20 minutes. So this is the time taken to reach his home again. Let us go for the first question. Over the time interval from 0 to 30 minutes. 0 to 30 minutes. In this time interval, the man walks from his home to the market by covering a distance or a displacement of 2.5 kilometers. So let us find average velocity. Average velocity equals to displacement by time. So the distance and displacement here both are same. So it is 2.5 by 0.5, that is 5 km per hour. Similarly, average speed, that is also 2.5 by 0.5, 5 km per hour. So this is the average speed and average velocity over 0 to 30 minutes. Let us find for 0 to 50 minutes. During this time interval, we can see the man goes to the market and returns home. So he is going to the market in 30 minutes and he is returning home in 20 minutes. So this was 30 minutes and this was 20 minutes. So 0 to 50 minutes meaning he has gone to the market and he has also returned to the home. So displacement is 0. He is remaining in the same position. He has gone there and he has returned. Distance between initial and final position is 0 because he is at the same initial point only. So displacement will be 0. But what is the distance covered? Earlier 2.5, now again a 2.5. So there's 2.5 plus 2.5, 5 kilometers. Now let us take the time. What is the time taken? 50 minutes. 50 minutes. 50 minutes meaning 50 by 60 hour. That is equal to 5 by 6 hour. Okay, now let us find the average velocity and average speed. Average velocity is displacement by time. Displacement is 0, by time is 5 by 6. So it is 0 only. Average speed is 5 kilometers by, this is total distance 5, by total time is 5 by 6. That is equal to 6 km per hour. So this is the average speed. Let us see for the last question, 0 to 40 minutes. Okay, here we have to understand During first 30 minutes, okay, during first 30 minutes, the man covered the distance of 2.5 kilometers during first 30 minutes. And then in next 10 minutes, he returns a distance. So in next 20 minutes, he returned home. So if 20 minutes he has reached the home, then in 10 minutes he would have covered half the distance of 2.5. Hope you are getting. So during 30 minutes he has reached the market. 30 minutes he has covered 2.5 kilometers, and then we have already seen in 20 minutes he is returning home. Again we have seen that is 20 minutes. Now they are asking for 40 minutes. First 30 minutes he did this one. So for next 10 minutes he would have covered half the distance of 2.5. If this is 2.5, then he would have covered 2.5 by 2, that is 1.25 kilometer he would have covered. That we have to understand. Now this distance is 2.5 kilometer. Now he is standing here. Okay, this distance is 1.25 kilometers. Now, what is the displacement? Initial distance between initial and final points. So this is, earlier it is 0, this is 2.5. This is, at this point it is 1.25. So this is his net displacement, this distance. Initially he was here, now he is here. So that is 2.5 minus 1.25. That is 1.25 kilometer. What is the total distance he travelled? This distance 2.5 and plus this distance 1.25. So 2.5 plus 1.25, that is equal to 3.75 kilometers. See, this is the distance while this is the displacement. Let us take the time taken. What is the time taken? It is 40 minutes. So 40 minutes meaning 40 by 60 hours, that is equals to 2 by 3 hours. Okay, so let us find average velocity. Average velocity is net displacement by time. Displacement is 1.25 by time is 2 by 3, that is equals to 1.875 kilometer per hour. Okay, let us find average speed. That is equal to 3.75, that is distance by time 2 by 3, that is equals to 5.625 kilometers per hour.